English and Vietnamese, and can be used also in the Vietnamese case. As a matter of fact, we already tested it in Mukanjan and when I was there. Other point, we have the GeoNode for uploading all the data related to the maps, and we are already uploading those data. And so I'll ask also the colleagues in Vietnam of considering doing that if they have some new data, because this is the container. This is the geospatial container, the shared geospatial container. The WebGIS is also working, and so good, nothing to say, it's working, thanks to the people maintaining it. Then with respect to the activity, we are still working on our case studies, but there is also a third case study, which is Valchiavenna. So we have Valtatano, Upper Valtellina, which was the second case study, and Valchiavenna third. And then as Tiong Chie will show us, we are now computing the susceptibility for the whole Lombardy. Those are some examples of different methodologies that we are using, because we are using different machine learning methodologies, and then putting all together using what is called ensemble models. Beside that, we are still working also on a completely different scale, which is the scale of a very high resolution, and specifically doing some UAV monitoring. Those are all the surveys made in case of the Ruinon landslide, which is a very famous landslide in Italy. So you see, in total, between 2019 2022, we had 12 surveys, and Basil will present also what we got from this part of research. Those are the publication of 2022, and so we are happy about what we were able to produce together. The objectives for 2023 is, first of all, to transfer and improve the susceptibility model on larger scales, so Lombardy case, and we will see the use of hyperspectral satellite images, which is a satellite of the Italian Space Agency, for mapping the land cover for selected case studies, and Professor Biagi will explain something about that. Then we are working about compiling a landslide inventory with the pre and post satellite images, and well, we will see what we want to do with respect to that. Working on deep learning models for landslide mapping using that inventory. We are going to continue the landslide surveys using UAV, and then obviously we have to maintain and update the web platform. And this is more or less the general overview about what we will do also for this year. And so at this point, I believe that we can start the true presentation. And so the first person who will present is Professor Biagi.
Oh, good morning, everyone. Okay, I can start the video. Can you hear me?
Yes, we
okay. Well. Oh, I'm not prepared technically. How I can share? Oh, yes, share the screen. Zoom is not enabled to access. Maria, I have to leave Zoom and then re-enter to allow the usage of the screen. Just 10 seconds.
Okay. This is due probably to the fact that he's using a Mac. I don't know. I believe because using a Macintosh, it could be that he has to do something before entering. Are there people expert on Macintosh here? So good morning, good afternoon, everyone there. I see Dong. I see Duang. I saw on Facebook that there were people still working last night for finishing preparing the presentation of today.
Yeah.
Can you hear me again?
Yeah.
Yes, we can hear you well.
Sorry for that, but when I started Zoom this morning, it required an update, and this changed some setting of the previous version. So, share the screen. Can I do that? Yes. Now I can.
Yeah, and we see your presentation.
Okay, I have to premise that we have not yet true results. We are in a very preliminary stage of our work. And Maria already introduced the purpose. The idea is that the identification of land cover is a really important factor in mapping the susceptibility for landslides. This is well known from the literature. And moreover, it is well known already that land cover can be mapped and can be analyzed by satellite-borne images. In particular, it is already a practice by multispectral images. Now, hyperspectral images are available. Our point was, can hyperspectral images used to have a better definition of land cover? On this regard, we decided to start a study on Prisma hyperspectral images that are available. What is Prisma? Oh, pardon, I'm quite confused for this technical problem that I had. And okay, Prisma is a mission, a satellite mission of Agenzia Spaziale Italiana. It was launched about 3 years ago. It is a sun-synchronous low Earth orbit with an altitude of about 600 kilometers, has a repetition cycle of about 1 month, has a planned lifetime of 5 years, covers as a polar, almost polar coverage, and the payload is an hyperspectral sensor with about 60 bands in the near infrared, about 180 bands in the SWIR band, and with a spatial resolution of 30 meters, and one panchromatic band with a spatial resolution of 5 meters. Prisma data, Prisma images are delivered with 4 levels of processing, from level 1 to level 2D, that is a geocoded level corrected for the atmospheric effects. And our first purpose was to co-register one Prisma image on a master image that is a Sentinel-2. What does it mean, co-registration between image? One image is chosen as master, one image is chosen as slave. Corresponding pixels are chosen in the 2 images and are used as observations in order to estimate the transformation between the 2 images. The transformation can be a simple translation, a similarity transformation, even to more parametric transformations. At the present, just one script for image registration was tested. That is the Geoinformatics library. It is a Python library. It is delivered in GitHub. And As I've said, the master image used was a Sentinel-2 image acquired in the same period of the Prisma image. What you see here is just the result of the transformation. And what has to be done in the future? In the future, we want to make an accuracy assessment of the co-registration, because as you see, I have not presented any statistical result yet. We need to analyze the residuals of the transformation. We need to analyze how much accurate is this library. And probably we will have to test other co-registration libraries in order to compare the results. And then we will skip to the final purpose, that is exactly the land cover analysis on Prisma image.
Thank you a lot, Ludovico. So I believe that we can leave the questions for the part related to discussion. So please, if you have questions, take note of them, and then we will, when we open the discussion, you can ask your questions. So thank you so much, and I want just to
I'm
recall
so
that
sorry for these technical issues that also distracted me from a clear discussion.
No, was clear, definitely. I want just to recall that there is also a master student working now on this topic, and so we will see in the next months the results about the usage of this new typology of data. Okay, thank you, and then we go to Basil. Basil presenting, yes, what we did with drones. Basil, floor is yours.
Okay, now you can hear me, I hope. Okay, so I'll briefly show our activities that are related to monitoring landslides using drones, and in particular, we are using, as already mentioned before, but for the people that don't know, we are using a consumer grade UAV, which from the point of view of regulations, national and European, are allowing us much more flexibility for the monitoring. So we are doing monitoring over the Ruinon landslide, which is in the Valtellina Valley, Upper Valtellina Valley in North Italy. We as a GeoLab, since the project started, did already 6 surveys, 2 in 2021 and 4 in 2022. Also this year we will continue, where at least another 4 are planned to do. But in addition, the local environmental agency was doing surveys from the years of 2019 to the 22, which actually are during the most active period, the most recent active periods of the landslide. Here as an example, I just put a few of the point clouds that we're obtaining using the UAV. As you can see, there is a bit of difference because the difference is mainly due to vegetation state change, because they're in different seasons, and then also there is a difference in the illumination settings. So the sun at different time was with throwing strong shadows, or it was a little bit more, let's say, constant illumination. All the products we're trying to share that we have produced, for example, the orthophotos are already uploaded on aerial map, open aerial map. So all of our surveys are there. The one from the ARPA agency, we're not sharing them, but if someone is interested, can request them directly from them. So what was the motivation of our study? We wanted to apply an algorithm to to measure the surface changes using one of the 2D products, so either the DSM, the digital surface model that is produced from the photogrammetric survey, or the orthophoto. But there are some issues that are related again with the observation settings. As I said, the illumination or the vegetation settings. Then, oh, sorry. As you can see, some of the features, some easily detectable features in one epoch can be easily detected, in the other not so much. For example, here be in May. If we use the DSM and we apply just a simple hue shade, also not really distinguishable features. So we decided to use red relief image map, which is a topographic visualization technique. So for example, here is the Pervotelina, and you can see all the pieces that red relief image map is using. This is the positive openness, the negative openness, and then we do a differential openness. And the final product is a red relief image map, and this actually highlights better the morphological features, which then for the algorithm that we're applying, it's much better. I'm going back to the example that you can see now. All the features and boulders are better highly detected. The elevation and the flat surfaces are better visible. This is because we needed this, because we are applying a computer vision approach to compute the dense optical flow, in particular the Lucas Carnot algorithm variation of it. Okay, so those are some example of the total red relief image maps that we also shared. In this case, we shared them in Zenodo as an archive. So when we apply the optical flow estimation, we can compute the displacement and the vector direction and the magnitude between two epochs. So starting from from July 2019, you can see that those are the most active periods of the landslides, where at some epochs the displacements are more than 15 meters. You can see some, let's say, as a holes that are appearing in the magnitude fields, but this is usually happening due to the correlation. So the displacement is actually much bigger than the search window. So let's say this point should be adjusted so we can have one continuous field. Yeah, then we can measure the total displacements for all the periods. We can localize some local displacements of the magnitude of a few centimeters and more. And yeah, we can also measure point by point for some specific locations that we're interested. And in general, the overview of the whole approach is that with the red relief image map, the RRMs, we are putting as normalized all the products, and so we have some, let's say, framework for standardized monitoring of all the approaches. We will continue the work also through this year, and we can use the products also to validate some observation using satellite images that we were doing the years before, and also we can validate those products using some close range monitoring. And this is the publication that we did related to it, published in the beginning of the year. And thank you for now.
Thank you. Thank you, Vasil. Again, thank you for the presentation, the work, and then again, the questions later. Now I want to give the word to Kyungjie, who is presenting her thesis. Oh, not finished, but good point. Okay?
Okay.
Yes.
Sure. I want to present
We see well. Yeah.
Okay, I want to present the topic of using ensemble methods to generate the landslide susceptibility maps. The method is first applied to small regions and then extends to the whole Lombardy. There are 3 small regions selected in Lombardy for this work. They are Vatatano, Upper Valtellina, and Vacchiavenna. The data points used in this study are same as the previous work. And the data pre-processing process is also the same as the previous work. And processing step consists of 2 parts. Firstly, chain 5 basic classifiers, that is bagging, random forest, ADA boost, gradient tree boosting, and neural work. And perform the evaluation of each classifier. In this part, 3 classifiers with the best performance are selected. Then the 3 ensemble methods, including stacking, blending, and voting, are applied, and the performance of each method is evaluated as well. They are based on the usage of different training datasets. There are 2 groups of scenarios. One group is using points sampled in the region for training. Vatatano, Upper Valtellina, and Vacchiavenna case 3 are in these groups. Knowing that the Vacchiavenna case 2 using the training datasets from these 3 areas is also in this group. Another group is using points sampled not in the regions for training. Vacchiavenna case 1 using the training datasets from Vatatano and Upper Valtellina. And as for Lombardy, no model is trained. The testing datasets are sampled in Lombardy but excluded from these 3 regions. Next is the results yet from this workflow. When the points in the regions are not are used for training, the 3 classifiers are bagging, random forest, gradient tree boosting, but when the points in the region is not used for training, the 3 classifiers with the highest performance are changed to random forest, ADA boost with calibration, and neural network. Therefore, these 3 classifiers are selected as the base estimators in ensemble methods. After applying the ensemble methods for the first groups of scenarios, both stacking and blending are methods have the good results, no matter based on the threshold, yellow profile, or optimized. While for the second groups of scenarios, only the self-voting methods look good. This is the one required to be further investigated and tuned. The landslide susceptibility maps are available for the ones who are interested, except for the ensemble methods applied to the Lombardy, because they are very slow and does not generate it yet. This conclusion my presentation, and thanks for listening.
Thank you. So thank you. Thank you, Kyung-jae, for your very nice presentation. And again, if you are interested in the maps, we have all the maps, but the Lombardy, which is still in computations. We are still computing the Lombardy map because it takes a lot of time. The 2 interesting points are considering different machine learning and the ensemble. This is the first point. And the second point is to train. We train these models in other areas and then apply the model once it's trained in a new region where we don't have training data set. And so the result that we got is obviously worse than the case when we have training data set, but in the end is not so terrible. So it's a medium level, we can say. For sure, it's something encouraging us in going toward this direction also. So thank you so much for your kind presentation. And if there are questions later, people will ask you. And now another new topic presented by Giulia Anna Leonardi. Giulia, are you ready?
Yes, I think I'm ready. I will see if I can share my screen. Okay. So, okay. I don't know what. Oh, so good morning, everybody, and good afternoon. I'm really happy to be presenting quickly some of the future work I will be doing with Professor Maria Antonia Brovelli and Professor Vasil Yordanov. And I will be focused, I will just give an outline of the future work, because as Professor Brovelli stated before, I will graduate later in June, so it's just an overview of the project we will be implementing it this next month. And so I will be focusing on building a global landslide inventory and then working with it as a training data set for developing a machine learning model on a collaborative platform. And I will try to run quickly over all of these topics. And so as I stated, the aim of the project is to develop this machine learning model that will detect landslide events globally using change detection. And the idea on that is to have the input data as the input data to satellite data sets from this area from 2 different dates, so pre and post event. And now we are actually creating this data set. And based on those input data, the machine learning model would, based on the differences between the images, would detect a landslide event. And the data we are planning to use is satellite data from Sentinel-2, and we are now contemplating also the possibility of including Sentinel-1 products also. So the workflow is well, the literature review and problem definition, and the step that we are currently working on right now, which is the creation of the training data set. So we are collecting data, the landslide inventory from different landslide inventories, and cleaning it, merging it together, and then collecting more and modifying the data sets so that the output of this step would be a reliable, robust training data set that we will then ingest into the model by implementing the architecture, training it, evaluating it. And this is also an iterative process where we are going to tune the model. And after that, we will assess the model accuracy on a test set. And finally, we would have the landslide detection model ready for use. And also, I just added these arrows that would mean that we will try to monitor also how the model is working on new data, and if it's not working as predicted, then we will go back and tweak the data and the hyperparameter of the model. But as I said, this is the future. Right now, we are working on just the data collection and trying to creating the training data set. And this is the workflow, which I will not be going into deep as I don't have much time, but basically the idea is to create first a landslide inventory, a global landslide inventory from different landslide inventory from all over the globe. So merging all of these in one file, and from that extracting the imagery from pre and post event, which will constitute the training data set. But the most challenges that we are having right now are from just finding the inventories that we could use to create that CSV file. So these 2 first steps, identifying available data sources and then creating a list of reliable data sources, are the main problem right now that we are facing right now. And so the challenges of these are, as I said, the finding reliable and accessible landslide data sources, because sometimes it's hard to access them, or sometimes we can find them, but then they lack some of the information, like the date or the exact location. And that causes us that we have more data in regions like Italy, where the data is more accessible. So we have a lot of points in Europe, but not so many outside of Europe right now. So this could be a problem we will tackle soon. And yeah, it's very important that the location and time accuracy is good. And also the problem is then to homogenize and unify all this data into one robust data set. And so this is for the data for the landslide inventory. And I wanted just to go very quickly over why we are trying to use a collaborative platform to develop this project. We are pairing up with a project developed by the European Space Agency, which creates this collaborative platform, cloud-based, to support research cases such as ours, and to develop all of these in a cloud environment, in a web environment. And so this collaborative platform will allow us to browse, access really heavy data as the Earth observation satellite data, which could be a problem to download on a local machine. So it's a very convenient way to work with such data. It will provide us a ready-to-use coded development environment and processing tools, and enable to perform compute-intensive analysis, which in our case is perfect, as we are trying to build a machine learning model, which is in fact compute-intensive. So we will use, and it will also give us the opportunity to assess this new solution for academic research in the field of machine learning for Earth observation. And so just introducing really quickly the platform we will be using. It's the Deep Earth System Data Lab, which is cloud-based, and it's focused on supporting actually the Earth science community with access to relevant data sets, and as a data science environment, which will focus also on providing tools for specifically for machine learning and artificial intelligence workflows, which is also an innovation in the cloud platform area, as before the machine learning workflow was not very much considered. And so we're very excited to try to implement our use case from A to Z on this platform. So that's this quick overview over the work we are trying to do. And thank you very much for your attention.
Thank you, Julia. So another interesting presentation, very clear. Thank you. And yeah, with the idea of also searching a new way for monitoring the landslide events, as a matter of fact. So Kyung-Jie, she's more working on susceptibility, on the opposite, Julia more on detecting the events. Okay, thank you very much. And then at this point, I leave the word to Professor Laura, I believe, or to Dr. Monica. I don't know who is speaking.
Okay, can you hear me?
Yes, well.
Okay, so Monica. Okay,
Thank you. The floor is yours.
Okay. Okay, so good afternoon and good morning in Italy. So I will present the progress of the work for the geological part of Politecnico di Milano. Today I will present something related with a rainfall threshold for landslide, in particular for shallow landslide and for debris flow. The presentation is organized as follows. So I will start with a brief introduction about thresholds, and then Andrea and Monica will present the two main technical parts of our activities. So if you remember, in the last meeting, we focused our presentation on two triggering factors for landslide due to climate change: the fire increases that may have an effect, may have an effect on landslide and the snow melt. We, in the last presentation, we tried to present by the use of laboratory tests the processes involved in this phenomena. But now we want to move on the rainfall threshold. Rainfall threshold is the most used instrument for shallow landslide and debris flow, and is used also as an early warning system. And of course, the nexus between climate change and rainfall is very strong and complex, and so is necessary to understand how can we adapt the actual thresholds to climate change. And so we are working on this topic. Okay. So we start with an analysis of a state of the art. A lot of authors work in order to define rainfall thresholds, and now we try to adapt to the climate change. In the last presentation, we work at laboratory scale, so very detailed scale, and now we move on another scale, that is slope scale, catchment scale, and also regional scale. But before start with the most technical part, I want to stress on the definition on threshold, rainfall threshold. That is the amount of rainfall or other hydrogeological parameters that, when exceeded, can generate a landslide. So usually two types of methods can be used. One is physical based, and the other is empirically based. The first one use slope stability models and try to understand if a particular rainfall may generate a landslide. In the second one, instead, the approach is more statistical. So move on the other. Okay, so here we can see an example for different type of rainfall events with different intensity and different duration. We try to understand if that particular rainfall events was able to generate a landslide or not. And so we try to define this division between landslide and no landslide. Usually the thresholds can be divided in 4 categories, and the most important try to use the intensity and duration of rainfalls. Instead, other authors prefer to use cumulated event rainfall and duration. As I told before, a lot of authors try to define thresholds. Here you can see several examples, but in literature you can find a lot of thresholds. It seems very simple to define this division between landslide and no landslide, but it's not so simple because as you can see in this slide, okay, as you can see in this slide, there are a lot of events and a lot of problems that may be considered. Several authors prefer to define site-specific thresholds, other seasonal thresholds, so that change and depends by season. And then there is also several issues like rain gauge data quality, sometimes the lack information, and thresholds sometimes are not related only on rainfall intensity and rainfall duration. Therefore, the goal of our work that now we will present only the preliminary results, and then we will work on this in order to define thresholds in the next workshop. The goal is to improve this threshold, to upgrade, to adapt the threshold to climate change. For this purpose, it's not possible to use empirical rainfall threshold because it's necessary to add a lot of events, and we have no events of the future. And so we decided to address this limitation in two ways. First of all, we will use synthetic rainfall by the use of climatic projection. And then after that, so with the triggering factor, then we use slope models in order to understand the stability of an area. And as I told to you, we work at a different scale, at 3 scale, slope scale, catchment scale, and then also regional scale. Now I will present the part of Andrea and Monica. So now Andrea will focus on the first part about the climatic condition. So how can we adapt rainfall for the future? So this part of climatic projection. After that, Monica will focus on slope stability models. But before starting with the definition of a new thresholds, Monica tried to use this model in a back analysis in order to understand if they work in a good way. So now, Andrea, you can start with the part of rainfall.
Okay, hope you can hear me.
Yes.
Okay, perfect. Okay, as we can see in this slide, we can see that Italy is highly subjected to geohydrological hazard, according to the ISPRA report that coming in 2021. But also the Italy territory is settled inside the Mediterranean climatic hotspot that is addressed to expect in the next future an increase in temperature, but also an increase in the extreme rainfall event. Looking at the literature, we can see that rainfall-induced landslide frequency will expected to increase, especially around the Mediterranean area. In fact, this is a study conducted by Gariano and Guzzetti in 2016. Next. Slide. Okay. So that we have examined several IPCC reports that are the Intergovernmental Panel on Climate Change reports that come in 2014, 2018, 2021. And we have seen that more or less the 10-year rainfall events are expected to increase both in frequency but also in intensity. And as we can see in the right part of the panel, an effect on this type of modification will affect especially rainfall-induced events such as river flood, flash flood, and landslide. Next. Okay. And in order to apply, for example, the threshold curve that already Professor Laura has presented, we needed to investigate about the quality and the affordability of rainfall data. In particular, we have two different instruments. Looking at the past, one of the most important instruments is try to take the measured data, but sometimes not always possible. So we need to implement and use the reanalysis data. Reanalysis data are the most up-to-date models that give us a reconstruction of the past meteorology and are useful especially in order to construct rainfall threshold, because it can be directly correlated with geohydrological hazard. Looking at the climate, okay, we needed to use the ensembles such as Eurocordex, that is an ensemble of different models that give us projection about the rainfall. One of the results is, for example, presented in these 4 panels that give us the seasonal change in percent of the maximum daily rainfall. and between a reference period and a future period in the up to the 2081 data. As we can see, there are several areas of our globe that will experience an increase of the frequency and a decrease of the frequency. And especially across the Mediterranean area, that is one of the most interested, we can experiment a decrease of this type of change, but is not always correct because we are looking only at the maximum daily rainfall. If we look at the short-term rainfall, an increase of the extremes is expected and is presented in the formula that is shown in the right. In particular, we can see that the future intensity will be subjected to an increase according to the increase of the temperature. Okay, next. Here is presented again another study that is much more focused on Italy, and we can see that the increase of the extreme rainfall will of course modify the intensity duration frequency curves that from an engineering point of view are really useful in order to define the several practices, in particular in the hydraulic discipline. So that if we look at the hypothesis of isofrequency, we can say that the magnitude of the rainfall event is directly related to the magnitude of the geohydrological hazard, so that in the future it is expected that the frequency and the magnitude of the geohydrological hazards, such as the rainfall-induced landslide, will increase according to the increase of the extreme rainfall events. Next. So that what is the possible scenario in the future regarding the rainfall threshold? Okay, are the rainfall threshold that we established in the past, as we can see in this type of review article, are correct, are sufficient for interpreting the new frequency and the new intensity of geohydrological hazard? This is an open question that we will try to address with the new strategy that are presented in the next slide. In fact, in order to address the possible climate driving of the geohydrological hazard, we need to have some model that can transform the climate data, the rainfall and the temperature projection, into information about slope and model stability. So that we have presented in the next slide, we will present in the next slide, thanks to Monica, several models that were applied by us in order to address this type of change, in particular the model crime, the smart cell model, and the trick model.
Thank you, Andrea. I'm closing now our part, showing you our results of the back analysis performed with these three models. Because as the main topic of our workshop, we need to assess the landslide susceptibility. So in order to understand where we can have landslides, we need to apply to study the climatic data applied to our territory. And so we need to use these physically based models. We decided to study, as in a back analysis, some cases and some areas of Valtellina Valley, because in this area, as we saw many times during our workshops, we had a lot of catastrophic events, as the ones shows in this picture. So with this model, we tried to understand when and where we can have the landslide triggering. We performed an analysis considering the USGS model called TRIX, which works at slope scale and assess the factor of safety of slopes. And also we performed a similar analysis at catchment scale, considering the smart set model from Politecnico di Milano, and the same analysis at a regional scale using a crime model, which is Andrea's model actually.
from his PhD thesis. So first of all, I'm showing you the results on these 3 case studies located in Valtellina. And as you can see, at a slope scale, we can identify correctly using this widely used all over the world model, correctly the source areas of the debris flows for Dubino, Tartano, and Albareto. Zooming out, we performed a similar analysis on Valtartano. In Valtartano in 1887, there was a catastrophic event that involved an hotel and a lot of people died. So we consider this event as a very catastrophic event, mainly because the rainfall event was very, very intense. So we have our SmartSet model, which is mainly a sediment erosion and transport model. And lately we added this landslide module, which computes a factor of safety considering the Montgomery and Dietrich approach, which is one of the simplest. Our study area is located here in relation to the valley. So this is our preliminary result. As you can see, after the main event, the main rainfall event, our model identifies as unstable a great part of Valtartano. This is because the calibration of the model is still a work in progress, but still at this preliminary phase, we can identify that after the rainfall event, after this huge rainfall event, we have some unstable areas where indeed there was the detachment of material forming our catastrophic debris flow. Again, zooming out, Andrea, during his PhD, performed a similar analysis on the whole Valtellina Valley. So at a regional scale, Valtellina is quite wide actually. And he performed the same analysis in the Apennines in another region of Italy. He also considered the climatic projections that he showed you in the previous slide. And considering the increase of temperature, the change of the rainfall regime, he observed an increase in the number of landslides in Valtellina. In the Apennines, the situation was similar because he observed an increase of the debris flow tendency. In the next slide, you can see the very complicated analysis from Andrea. Here there are all the analyses he performed to connect the climatic projection to the instability using the crime model. So in conclusions, to study the problem of landslides, we need rainfall thresholds, which are actually a very complex problem and still an open problem that is needed for landslide hazard mitigation. It's an open problem because rainfall thresholds also evolve under climate change conditions. So the climatic projections are very important to understand the impact of this rainfall regime change. And it is also important for the special prediction of instability that is our common aim. Therefore, we performed the back analysis of past events to identify the most critical areas in different places in Valtellina. And secondly, we applied the climatic projections using the crime model to understand the impact of this climate change, observing a positive trend between rise of temperature and landslide occurrence. In the next months, we will quantify better our thresholds, under climate change conditions. we will update the actual thresholds, and we also are going to improve this new landslide module of our SmartSet model that I said before. It's mainly related to erosion and sediment transport at the moment. Thank you very much.
Thank you. Thank you so much also for a very clear presentation, and congratulations for the work. Congratulations for all the work, and specifically the work done for the PhD, which is really impressive. So thank you so much. And yeah, I don't know. Now it's in principle, it's time for the break. I suggest doing our 5-10 minutes of break, and then convening back again. But in
I had a presentation for the education part.
Yes.
Okay, Basil has another presentation.
It
Sorry,
will be
I
quick.
forgot it. It's very, no, but it's very short. Okay, we
Yes.
have the presentation of Basil. I missed it, so sorry, Basil. But yeah, it's also because this is something in common together with us and the colleagues from Vietnam. Okay, so
Yes.
Basil, go ahead, please.
Okay, just briefly to show what we're doing as a part of the project related to education. It's actually an initiative that started last year, and we already have both students from Politecnico di Milano and Vietnam from Vietnam Partner University participating collaboratively. So you can see this was from last year activities. Actually, what we are offering, it is part of the Geoinformatics Engineering, which is a master degree in Politecnico di Milano. It's international program taught in English, both for Italian and foreign students. Mainly focused on students with environmental science background that will take computer science courses, and then students who have already some computer science backgrounds, they are taking also courses in geomatics and environmental issues. So as a part of the geoinformatics program, the Geographic Information Systems course is offering collaborative practices and laboratory to the international university. So mainly now to Vietnam University, and we're offering them 30 hours of practice in GIS and 10 hours of joint laboratory that it's focused on a specific landslide topic. This year we have around 50 Polymie students and around 25 Vietnam students. Of course, those students need, need some tutors. So we have tutors also from Vietnam. If I'm not wrong, they're actually now this year they're tutors, but last year they were students and they were taking part of the course. And now we have also tutors from Politecnico. The assignment for the laboratory is again to compute a landslide susceptibility map of different areas, and to compute the landslide hazard exposure and some factors, some exposure, in this case the population exposed to hazards, to landslide hazard, and then the results to be presented in a WebGIS environment. So we're showing and teaching only, again, open source software, QGIS, GeoServer, open layers, and the data that we're using, more or less, we try to put it under a common framework, even though that we're working on case studies both in Italy and Vietnam, but still we have common data sets such as terrain, land use, some infrastructures, and DVI. And then we're also using World Pop dataset for the population exposure. And here just the different case studies that we are using for both in Italy and Vietnam, and to cover all the students different cases. Okay, that was it from me quickly. Thank you.
Thank you, Vasil, and sorry for forgetting. And then probably there are also a couple of more tutors from Vietnam to be added, but then Quang will update us with respect to the course as well.
Yeah.
Okay.
Yeah. Thank you. I
Yes.
will ask someone else, my colleague or student, who can become the tutor and make the final list and send it to you. Your
Yes.
question is adding 2 tutors, right? Maya?
Say it again.
You asked for adding 2 tutor more or to the list?
If there is the possibility, is better, because as you see, this year, the GIS course is really successful from one point of view, because we have 50 students. It means not only students from the Geoinformatics engineering lab, but also from other masters who want to attend the GIS course. And so having 50 students, if on your side, if you think that 25 Vietnamese students can be well tutored by the free tutors you propose, that is fine. And if you think that is better to add more tutors on your side, I believe that this can help students if they have problems.
Yeah. Okay, I agree. Yeah.
Anyway, the all the material will be available, and therefore students can follow the lesson first of all, but also catch up with the lessons. But specifically when they have practical problems, is good to have more people to speak about. If not, the risk is that the free tutors will be very busy in answering all the questions. But it's more or less up to you. It's just a suggestion of mine. Think about that, if it is can be useful of adding some more people who attended last year, and therefore can become the trainers of trainer. Yeah. Okay. So thank you. So it's good now. Now, Vasi, do you want to say something more? Do you have other presentations?
No, finished for today. Thank you.
Are you sure? Are you sure?
If you want, I can search for
Okay.
something. No.
Okay, yeah, I'm joking. Sorry for missing your presentation. Yeah, and Professor Kwang, do you think that is now we can do the break, the 10 minutes break?
Yeah. We have 10-minute break. Thank you. Yeah.
Okay, fantastic.
Thank you
10
for
minutes, no more, because we have
discussion.
to finish by midday. Okay, thank you. See you.
And it's give us nothing. For instance, here there is no correlation between the rainfall, the daily rainfall with accumulation rainfall 3 day, 5 day, and etc. So this is not the way to create it. So the Dr. Ha, who's have us in this section, they found that the rainfall, maximum rainfall daily, have some had a big relation with rainfall events. So we create the function like this. And if we compare, we try to test with rainfall from 2015 up to 2019. It's worked well. It's given about 70% of correct landslide with losses, and about 30% is strong. We don't know landslide or not, okay, because it's no reported from people. This is only at this time only the way we find the landslide rainfall trigger landslide by this way, as this is a very simple statistic model. And we have to look forward for Professor Nhân to find it more by using the geotechnical or geological model. For that, he will present later. And for instance, we can use that function to find during the rain in the May, we can find a lot of small landslide along the road in Mukang Chai districts. And it is for landslide monitoring system design. We have two sources, one from global, let's say ZPM, and we have a rainfall storm Gauss station. So we will capture, process, and cut if they are from the public sources. We have to cut and put it in the geo database, and we do some processing, and we try to find the threshold, and we can make the landslide map. Let's say it's a near real-time landslide map, but still now I don't know how to combine the rainfall data and landslide susceptibility map to become the landslide map. For instance, in the very flooding area or storm time, I have to report, I have to establish every 12 hours one map during the different the change of rainfall, like rainfall 30 minutes rainfall, for instance. Yeah. And for the interface and the system, I want to change the simple technology. We use just only normal GS and HTML before we use Angular, but Angular is very difficult to do something more. So we change, and we also need to install GeoNode as much as possible, and we will have something, let's say, complete if I can finish on this one. And for the, oh, sorry, this is not in the slide. And for geological survey, so is now we are working separately, but when I check in the landslide susceptibility map, it's also in the red, luckily. And we have two different locations of geofield survey. One is in Mukang Chai and one is the Van Dien district. It's two different districts. So this is some result from geological team. So Professor Nhân will present. Thank you for listening.
Okay, thank you, Quang. I say some word on our part. We are the part of Quang project, so I like to focus on a landslide monitoring points in Mukang Chai and Van Dien in Bai province, where we have 2 points for the landslide monitoring. We would like to, data outlines. We like to present the objective and method we apply for and study area. Okay. Em cứ chiếu trên đấy, em chiếu trên đấy, còn tôi trình bày đây là tôi nhìn vào đây thôi chứ. Em nhìn vào cái file của tôi để mà. Sorry. A bit. Em cứ theo cái file của em này, bởi vì file tôi có màu. Từ tắt đi đúng không? Không cần có PowerPoint. Sorry. Là thầy tắt mất cái PowerPoint. Okay.
Sound screen.
Okay, so you have my presentation now. So I like to focus on the land monitoring points in Mukang Chai and Van Dien in Bai province. This is a part of a Quang project. I like to present the objective and method, study area, and the activity we have done, and we also working in the coming times, and yeah, like a follow-up. Our objective is we like to set up a monitoring point for the landslide in the study area. The point is we like to focus on a landslide monitoring for the validation of a susceptibilities map, as Quang mentioned last time, and you know, for the verification of his method. That is our objective. The methods we try to apply the surveying by drone. I remember that the last time we have designed the design of from the drone measurements at the two sides. And the second method, we like to apply the geophysics measurement at the side. And the third one, we try to drilling for the borehole, so that we need to get the coring sample, and also the groundwater level measurements and monitoring as well. And we taking the undisturbed soil sample for geotechnical purpose. And we have monitoring groundwater level. It means that when we drilling, and then we have installed the casing screens, and then the monitoring of the groundwater level over time. And the last one is using the geoslope for stability analysis, soil and rock slopes, and comparison between the result of you know, result of monitoring points with the map Quang did it by AI and remote sensing. Yeah, that is in by. I don't want to mention quite take time. And you know, we have a 2 point for the to set up the monitoring point, that is Mù Quang Chải and Văn Yên and Yên Bái province. Yeah, as I said before that, before we have to select this two sites, we have a drone measurement. So we found that this is quite a susceptibilities landslides, and also the, you know, the symbol to show the landslide later on. This is a Mù Căng Chải site for landslide monitoring. You see here, yeah, that is scat. You see that is the road. It across the hill, so that's it's quite clear that the landslide is happened sometime. And now we just measurement of geophysics to detect geological layer, and also to take coring sample. Here is a point at Văn Yên. It's a second point. It looks quite the same as Mù Căng Chải, but you see here that is also on the road, and it's the hill at the left of the road. So it also see the picture, and the right hand side you see the landslide happens. Okay, so we have a geophysics measurement. We apply the vertical electrical sounding measurement. It's a two side with a 4 line and 72 points. That you apply the slope measure array with AB. It's a distance maximum 440 meters. And yeah, that's a two pole. Short pole is 100 meters because of you know, the structure here and geological condition at the Mù Căng Chải and Văn Yên. You see the some interpretation from the vertical electrical sounding. You see here it's in the upper is a weathering zone, and below, the fracture rocks, and also, but here it's almost quite metamorphic rocks, and the landslide is quite clear that it's quite a top in a weathering zone. Even the vast measurement result also show you the shape of the landslides. And then we, that is a interpretation of geological cross section at Mù Cang Chải. You see here, it's this below is quite rock, and I think like a hard rock, but the second layer is hard rock, but less weathering, and top one is a weathering zone, and which the landslides shape you see here. It's at the two geological section you can see here. Okay, so based on the vertical electrical sounding, we see that the slide length about 30 meter, and the depth of the slide surface is about 20 to 25 meter, and slide angle is around 40 degrees. I mentioned again that also here the quite metamorphic rocks and weathering zone in the upper part. Yeah, it's the drilling at Mù Cang Chải. We have two borehole with drilling depth at 20 meter per each borehole, and we taking undisturbed soil and rock sample for the soil and rocks properties, and the depth of weathering rock here, we found that it's up to 80 meter depth, and groundwater level it's drop very low at 18.2 meter. We can measure the groundwater level because of after drilling we installed the casing and screen for the groundwater measurement later on, and monitoring later on as well. We did the same at the Vạn Yên, the second point. You see here, that is a cross section. That is a vast lies measurement at Vạn Yên, and also the cross section interpretation from the geophysics measurement. And found that's a slide length about 20 meter, and depth of slide surface about 5 to 7 meter, and slide angle is 11 degrees. So yeah, and then we have drilling. We have two borehole drillings, and as the same in Mù Cang Chải, the depth of borehole about 20 meter, and we also taking the undisturbed soil and rock sample for the soil and rock properties. And here we found that the depth of weathering zone 5 meter, and groundwater level is higher than Mù Cang Chải. It's 5.7 meter. That is all about activity we have done so far. For the prediction of landslide, we use some theory, and also the geoslope model later on. But so far just only a theory, because of we still sending the soil analysis, still waiting from the laboratory. So that's we don't have any data for the soil property at all. So that we still waiting, and also we're waiting for the groundwater monitoring over time, and then we put in the geoslopes model, and then we will predict, we will calculate when, or you know, the what about the gravity level, and yeah, and we makes the slope happen again. So that's our future activity. Thank you.
Okay, thank you, Professor Nhân. So I would like to invite second present, Khúc Thành Đông from Hanoi University of Civil Engineering. Thank you.
Okay, good afternoon, everybody. Thank you for having me this conference. So I am Khúc Thành Đông from Department of Geodesy and Geomatics Engineering in Hanoi University of Civil Engineering, and currently I am PhD in Hanoi University of Mining and Geology. So today I would like to present our results untitled Landslide Accessibility Mapping for Mù Cang Chải and Văn Yên District. This is my outline in the 4 parts: introduction, methodology and data, result and discussion, and conclusion. So first of all, I will talk about quickly about the landslide. The hazard phenomena are very dangerous now, and we have the some kind of landslide, like you can see on the slide. So there's we have some of the causative factor for landslide. Is depend on the topographic, geological, or some environmental factor. So to create establish the landslide susceptibility map, we need some of step. The first is we have to identify the landslide factor. It depends on the case study, the you choose, and the most of factor is in the group, the topographic, geological, and the environmental. So after that, you will collect the data. Based on the what the kind of methods you choose. So for some statistics and the machine learning methods, you have to collect the landslide inventory. It can collect from the field trip or the some of the observation techniques, Earth observation technique, and after that, the topographics, you can collect the elevation data, elevation map, and can establish the aspect curvature. And we have some of the hydrology map, like the river network or the topographic west index, TWI, or the stream power index. And the third step, so we is to create a database and for matching the information between the landslide sample points and the cost factor data. And the next steps, we use the modeling to the relationship between the landslide state and the cost factor. And after the last one, we need to validation between the model result and testing data for evaluation the performance of the model. So For more detail, you can see on the slide that's the based on the cost factor. After we extract the values, you use the GIS or model to analyze and establish the landslide susceptibility map. Based on the landslide inventory, we divide the training and testing data, and after that, extract the factor data based on the factor map you choose. So use GIS and models to build the LSI map, and after that, use the value that you calculate, you remodel to validation your model. And so we have some kind of landslide susceptibility modeling. The first is based on the specific knowledge. We have the ASP methods or the fuzzy logics and so on. So the second is the statistical, for example, is the frequent ratio or the ABF methods. In the last presentation in the November last year, I present the ASP and frequent ratios, and in this presentation I will show the result of the machine learning model included by the support vector machine and random forest, and we have some compare with the traditional the model. So for those landslide susceptibility modeling, in this study we use the random forest models. These models based on the forest of the tree, where they choose the random of tree, and after that we are voting to choose the best of the model. And the support vector machine based on the binary classification for the it's for the linear classification, and for multi-vector we use the surface to divide the landslide states. That's the landslide or landslide, non-landslide or landslide. And the study in case study here, I work for the Van Yen, and actually we separate the Van Yen and Mugang Shai to case study. Yeah, and so I will work first for Van Yen, and we applied the process for Mugang Shai also. And that's the data used with the elevation aspect, the curvature, yes, and for the slope geology and the broad river, yes, and some of the index of hydrology, yeah. And for the result, the two map in the left side, we can see the susceptibility map for the ASP and frequent ratio in the last time I present. For in the right side, we have the support vector machine mapping of support vector machine model and the random forest. So we can see that in the Van Yen district, the high and very high glass is along the road, and especially in the national road and the province roads of the Van Yen. And so we the map show that the random forest have the better than in the classification of the moderate class. While the support vector machine is this model based on the binary classification, so it's the classify the clearly of the high, very high, and very low value. So for the accept for the assessing the model in the left side is the AOC of the frequent radio and the ASP model. It's the from the 0.7 to about the nearly 0.8. So for the in the right side is for random forest and support vector machine with can see that is the AOC is over 0.9. And that's the result is I apply this process to the other Geo database is for Mukang Chai district. We have see that's the result is so the random forest is the best better than in the classification for the moderate value. So and the right side is we can see the value of the AOC for both model. So when the conclusion we can see that this study successful in apply the to machine learning model to establish the landslide accessibility map for Van Yên and Mukang Chai district. Yes, and the AOC we get the over 0.8 or on of this model. So and we can see that the machine learning model provide good performance when we compare with the traditional methods, and the spatial distribution of high and very high susceptibility landslide is along of the roads and in the higher slope. Yeah. Thank you.
Thank you, Dong, for your presentation. So I would like to invite last presentation, Trần Nhật Dương from Hà Nội University of Science Technology.
So good afternoon, professors, lecturers, and experts here. And I'm very glad to be here today to talk about the machine learning-based approaches in landslide susceptibility mapping and landslide detection. So the machine learning is widely used around the world to handle the complex data from the topography, geology, geomorphology, environmental and planning factors, and to produce the landslide susceptibility map as a process of risk identification. And for the landslide susceptibility mapping, I use 4 machine learning models. It's like a traditional methodology of combination of random forest, gradient boosting, AdaBoost, and baking method. For all 4 methods shown here has the same issues, that it tends to be overfitted when training the model and predicting the landslide susceptibility, but it has they have their own hopes. For the random forest, it has the ability to handle large datasets and is very robust to the outliers. For the gradient boosting, it has the ability to handle non-linear relationship between variables and produce high accuracies of the result. For the AdaBoost, it has the ability to handle complex city of the data and its adaptability to different data distribution in the whole data set. And finally, for the bagging, it has the ability to handle high dimensional data, and it has the noise study when training the model. And to reduce the overfit problem and the bias problem, for the methodology. So I combine 4 models to in a voting model called the voting regressor. And yep, the voting model here has 2 types of way to predict the landslide susceptibility. By the hard voting, the model will be trained based on the 4 proposed machine learning algorithms, and it will choose the majority voted model to become the main regressors of the main regressor as a predictor. And for the soft voting, that the prediction will be reduced to the average combination. Yep. And for the challenges of implementation of the voting model, that the model selection inside the voting model between the 4 proposed algorithms. Yep. And I wonder that whether I choose the 4 proposed algorithm here is right or not, or maybe it can reduce the accuracies of the whole model. And for the second challenge here is the data and the data pre-processing. Yes, and of course we need to consider the quality of the input data, and the pre-processing method is suitable or not. And also, as I said before, the overfitting problem is also a considerable factor that affect the whole model. But we can use the hard mode or soft mode to choose the right way to post-processing the prediction, and also we do the model refinement to better choose the suitable hyperparameters. And the final challenge is the interpretability. If because we don't know that what is the change model do, because it's like a black box, and are the results good enough to make the communication to the stakeholder and the community. But every challenge will have their own solution by making trials and do the model tuning in the machine learning approaches to optimize the whole model. And here is after making many attempts for training the voting regressors, and then I came up with the best model with the ROC AUC score of nearly 0.9, and also the susceptibility here is along with the landslide inventory is very it's not really right, but it has the tendency of produce a good result. And for the landslide detection problem, here I use the UNet architecture, and it has the pros and cons. For the pros, it has the ability to capture all the information from the locality and globality, or I can say in different way that it can handle every data, and its disadvantages is the training time, because it take time to train the model with a lot of training parameter. It can be up to million or billion train parameter. And the overfitting is always a problem in all machine learning problem. And the UNet has the sensitivity to the data noise, and it is also is like a black box for interpretability and generalization of the data. But it has the condition for succeeding in prediction. But we need to make sure that the quality of the data set is good enough, and the size of the training data set is big enough, because if we don't have a big enough data set, we can face to the overfit problem. But the efficiency of the UNet architecture is not really good, because after using UNet for prediction, we need to do the field survey to make sure that the landslide prediction is good or not. And for the process of applying the UNet, the first thing that I need to do is do the data collection and pre-processing the data, and the training data is obtained from the Landslide for Sense competition, and I do the pre-processing by normalizing all the band and obtain just 3 normal RGB band for training. And I do the train test split by the ratio of 0.7 and 0.3. And then I use the train test data set for model fitting to change the data for landslide prediction. And finally, I make prediction on other Sentinel-2 images from the Mù Cang Chải and Văn Yên district. For this process, I need to patch the whole image to adapt to the size of the training input, and I predict the landslide on the patches, and finally I combine all the patch into the original image. And the result of the landslide detection shown here is just a preliminary result that may contain the wrong prediction as a clouds or wrong ports. And finally, I would like to talk about the sustainable process of making the landslide susceptibility and landslide detection here. First thing is the data collection and pre-processing. The second is feature selection and model development. This step take times. And thirdly, the model evaluation. And after we do the prediction, we can we must do we must do the sustainability assessment as such as do the social or economic assessment to see whether the prediction is suitable or not. Next, we need to do the model refinement and stakeholder engagement. For the model refinement, we need to do the model tuning to optimize the whole model for the best prediction, and do the stakeholder engagement as long as we have a new result or the update data set. we will run again the model and do again the sustainability assessment to make sure that the model is suitable for a long-term period. And finally, we do the implementation and monitoring of the result with the communication to the community. And so, in conclusion, I will talk about a takeaway summary that the voting model and the UNet architecture are really good and initiative to develop a good way for landslide monitoring. By combining the voting model and the deep learning approaches here, we can produce a better result by combining not only the model on the paper and also the practice on the field survey. Thank you for listening.
Okay, thank you, Joe. And thank you all for listening. Yeah, so we move to the last session, discussion session. Thank you, Joe. I give my speech for you. So you manage is always better. Thank you, Maria. Yeah.
No, thank you. Thank you to the team for presenting very interesting research. So it's impressive how we have been able in these years to grow up, as a matter of fact. If you think back to the first meeting we had in the beginning, and so how much we did, I'm really impressed. So congratulations. I believe that we have, first of all, to congratulate to all the people here for doing such a good job. And then, yeah, I believe that it's time for opening for some questions. Are there questions?
Yes, so I have some question about geology part because it's a very interesting and very important job, but presentation time is quite short. So during the break, I asked Professor Laura, and she said there is open data around the world because I say something about that data in Vietnam is very difficult to get, and she suggests that we have one of the models they are already they are using is using open data. So maybe I will ask Professor Laura and team to have us to look at together on the morning Fridays. So and I think we can have some thing to do, and we can see what is good for that kind of model. And I think for GeoNote, when I was present, Maria asked, told that I don't need to install. I don't know much. I don't understand that much. I think I need to build environments, and then that is something to run this directly without installing, as I not draw. Is that correct?
Yes, I believe, yeah, with respect to that, I believe that is good if we give a very simple demonstration about how to add the data and the container. So I don't know if Basil, when Quang has finished, you can show to everyone how it works, because it's very simple. No, but go ahead. It's just because this is very simple and we can show you, but please go ahead with your question.
Sorry, any question from online?
So let's do in this way, Kwang. You have two questions. First of all, the first question Professor Laura can answer.
Yes.
And the second question, Vasil will show how to contribute data to the GeoNode.
Yes.
Okay?
Yeah.
So Professor Laura.
Okay. So can you hear me? Yes. Okay. Okay, we have discussed during the break about the possibility to make an application of one of our geological model, in particular SmartSed, at catchment here in Vietnam. And so we will discuss during these days the best choice and the best catchment in which we can try to work together in order to define the mass movements in general and landslide. Okay, so for this, we will discuss during these days.
Fantastic. That is exactly the aim of going in the place, because it's much easier to discuss with people.
Yes,
the online meetings are very useful, but in-person meetings are generally definitely richer. Okay, I'm very happy about that. And then Vasil, can you show the GeoNode? First of all, put in the chat also,
Yes, I'm
which
about
is
to do that.
Yeah.
The link is, oh, no. Okay, so Quank, I think we should create your account. I think you already have actually with administrative rights, so you can also upload. But the account mainly is to upload data. Otherwise, it's free and you don't need even registration to enter the platform and to download. The easiest way is to go to data and then
Sorry, Vasil. Probably is good if before you show what can do people without the account, so normal users, and then showing what can do the people with the account, the administrators.
Okay. Okay, so as you can see, I logged out, so you can directly enter the platform and go and to explore the layers. For now, we have only the layers for Val Tartanu and Upper Valtellina, so we put all the rasters, all the grids that we used for the susceptibility modeling. We have the one of the utmost latest versions of the susceptibility mappings. And also we uploaded as vector layer the training points. So on one side we have the inventories that we were using. Then we have also the no landslide zones. What we have defined here is the condition, what we are using as presumably low possibility of landslides. So basically the areas that we're using as to train and test as absence of the phenomena. And then we have actually the points that we have created for testing and training the models. And they're already sampled. So in the attribute table, you have all the data underlying them from the environmental factors. Once you enter in one of the layers that you want, there is the name, the style. Usually it is added if it is a raster, and then you can simply download the layer and use it as you wish. See, it's with legend. The attributes you can check in the the vector shapes, the tables. Yeah, Okay, so the data is here. We have it, should be tagged by, okay, yeah, they're divided by regions of interest. So we have also the boundaries. You can filter raster or vector. In this case, you can see this the buffer that we created around the river network with different distances. Okay.
Sorry, Vas.
Yep.
How did you install this journal? Using Docker or?
Yeah, I think it is installed from Docker image.
Yeah.
Okay.
The system is Ubuntu or what kind of Ubuntu?
It's on a server of Polytechnico.
Hmm.
I'm not quite sure what is.
But again, Kwang, now you see how to download the data, but if you have a datum, a map, you can upload it.
Yes. I already upload a lot of data on the GeoNode text. Yeah, because
But not here.
Yes.
Because
yeah. I can upload
Where?
some data, but not all, because I don't know they allow to upload all the data or not. But for instance, data related to DM and like drought and something I can upload. I can upload again. I will upload. It's also good for GIS course because student can upload directly from this kind of system.
Yeah,
Good.
exactly. Yeah.
Good.
Sure.
Yeah.
Sure. This is a collaborative platform. That is the reason why you don't need to have another collaborative platform. One is enough.
Yeah. Thank you, Mario. Yes. I will upload our data to GeoNodes or Polyme. Yes.
Yeah. Specifically, the data that students will use for their computation. If you put the data here, the students can download immediately all the data from here, and it is becoming easier. And then when they create their susceptibility map, they can also upload here the susceptibility map. Yeah. Yes. Okay, so if all of you is fine with this presentation of the GeoNode, I have a question for our colleagues, and specifically, probably I didn't catch it, but what is the threshold that you use for creating the susceptibility map? Do you use simply 0.5, or do you consider the ROC curve? So what was the procedure that you adopted for deriving the susceptibility map?
No, but our map wasn't a proper susceptibility map. It was simply a map of the factor of safety. So now my PC is out of charge, but I showed you an equation related to the computation of the factor of safety that depends on the thickness of the soil, cohesion, friction, slope angle, and combining this data with the soil moisture amount that comes from the intensive rainfall, we got that result. We also got different result with different formulas, but that one was the most feasible to our case study. So we decided to show you that one. But as I specified, that work is still in progress because this is a very new module of our model. So the result is not perfect. It overestimates a lot the critical zones. But it changed after the rainfall, so we decided to show you this result in order to show you a combination between a soil moisture that changes over time because of hydrological process, sorry, not hydrological, but I'm so tired, only shallow hydrology processes. And so rainfall combined to drainage and so on changes the soil moisture that change the factor of safety in our study area, but it's not properly a susceptibility map. We didn't consider all the factors as you did. It's a different process, it's a different procedure, and we didn't assess a probability of failure. We just said, right, we have a low factor of safety, so there can be instability, but it's not a probability.
Yeah. Thank you. Yes, and what about the maps computed by the Vietnamese colleague on the opposite? With your maps of susceptibility were computed using which threshold?
Thresholds. So we use regressions. This is not binary prediction, not classifications. The outcome of model is not classifications, not only 1 or 0. So we use a threshold. Regression is, I think, is 0.5. 0.5, right?
I'm sorry, because I developed a function to calculate the best accuracy between the choosing the threshold from 0 to 1, at which that the best thresholds produce the best accuracy, then the best threshold can be produced.
Yeah, but how do you compute the best threshold? This is my question. Because you said you choose a threshold between 0 and 1. Yeah, fantastic. But how to compute the best threshold?
I'm sorry, I didn't get the question.
You said that you used the best threshold. But my question is, how did you define which was the best threshold?
For the method that I optimize the thresholds is that between many attempts to increase the number from with 0.05 with each attempt. So I mean that for the first attempt, the threshold will be 0.05 and the second attempt is 0.1. And with each attempt, I apply the threshold to the prediction of the request prediction to obtain the 0.01 classification, and compared to the true mass of the I'm sorry, choose hazard label on the test data, and if the accuracy is higher, then I replace the last accuracies by the next accuracies. Do you get my idea?
No, sorry, not. So the accuracy, you computed the accuracy starting from what? Because for computing accuracy, you need to have ground truth. And which ground truth do you have?
I make a loop between 0.1 and with each with a step increase step of 0.05. Yes, and with each increment, I will apply the threshold to the prediction. And
this is clear. This is clear. It's between 0 and 1, yep. And you added every time 0.05. So you created all the maps. But the point is, how did you choose the best one?
With each attempt, I mean that at the previous, I can assume that the previous attempt, the threshold produced the less accuracy result, and the next increments will produce the higher accuracies of the result. Then I replace and then I choose the like the how to say. Có nghĩa là
Okay, but it doesn't matter. It doesn't matter. We will need to discuss it because again, I didn't understand. Probably I'm a bit stubborn, but yeah, but it's okay. We will discuss separately. It's not so important now to discuss about it. And yeah, I'm pretty sure that I'm not able of understanding the procedure, but the procedure is clear. Yeah. Other questions? Yeah, I see Vincenzo.
Yes, good morning, and thanks for this opportunity to follow your activities. So congratulations for all the works and the presenters. I am an intern from UNSpider, and I'm wondering if there is any satellite-based technology or software which that is used that is able to understand the landslide risk and hazard worldwide, such as GLOFASS for floods or Global Drought Observatory for drought.
Okay, thank you.
You're welcome.
So the first answer is unfortunately not. There is not a service like this one. Is much more fragmented, the problem of landslide. And also the other point is that generally the resolution of the effect is not so compatible with respect to the open data that are available. So the open data starts from 10 meters, as a matter of fact, of spatial resolution. And therefore, very often we have that the phenomena, specifically if they are continuous in time for a certain time, are not moving faster than that it's difficult to see them. We have some example of monitoring where we were able to detect or to monitor the landslide, but using satellites which are not open, as a matter of fact. So, but it is under study. So what we want to do, for instance, with Julia, is exactly to check what is visible, considering the pre-event and post-event of known landslide, and to try to train a machine learning model for detecting landslide. But we are a bit far from being sure of obtaining sure result. Is an attempt, as a matter of fact. Yeah. Obviously, that is different if you use other technologies like UAV, like aerial data. That is another story. But obviously, these are here and there, are not satellite data. Yeah. And but I don't know if somebody else wants to add something. Vincenzo, are you happy about?
Yeah, of course. Yeah, Professor, thank you for your reply. Of course, it is an issue. It's tricky to monitor the landslides due to, as you said, the lack of data, and of course, it is a threat that is going to increase, but it's not maybe perhaps serious, such as drought and floods. So happy that that works, and there are some updates on this point.
Anyway, there is also a platform, a TEP, thematic exploitation platform, that can be used for doing some analysis related to landslide. I believe that this is the most general, even if it is not open. So no, it is open, but it is not free of charge. And I don't know, Julia, do you want to tell something about that platform? Because she attended just a couple of days ago a meeting together with Vasil, with the people of this GeoTep.
Yeah, so I mean, on the JEP, so the GeoTep is more for, there are different hazards that they basically provide services to analyze hazards such as landslide too, and they have a couple of services such as some machine learning models to detect landslides, etc. But it's still it's a community-based platform, so it's yeah, and I'm not sure if actually the landslide part, I think, is not, I mean, it's not free of charge, yeah, as Professor pointed out. So it's definitely would have, it's, if you want to do some analysis on the JEP, it's better to contact the team and ask for a sponsorship, or yeah, but it's not an open source, open software for everybody to do analysis.
The interesting point is that you have there, in any case, the satellite data already included in the platform. So you don't need to download the data, and you find also there some pieces of software, some shared, I believe, Jupyter Notebook or something like that, correct, Julia?
Yes, so it's Jupyter Notebook for your own analysis, but there are also applications that are just pieces of software in which there is no coding experience needed, and for specific cases, it's possible to just input the data that is needed for the software that is developed. So it's kind of app based. So we have an interface with the map, and then on the map the satellite data that is available is shown, and which data can be used for further processing. There are different softwares that as input take usually satellite imagery, and then depending on the software there are different analyses to be done. So it's kind of this app store with different applications. You could different analysis you can run on satellite data specific to landslide monitoring, but also earthquakes, I believe. So it's kind of a variety of analysis to be done on a platform, which is it's nice because you have already access to all of the data, the satellite data, and to the app itself. So no installation on local machine is needed. And yeah, it's if you have a specific use case for using that kind of application, I think it's worth exploring the JEP. Yes.
Yeah, and it could be that there are some agreement with UN, with the UN agencies, also UN Spider in case, but because we are not the owner of that platform, we simply had some contacts with them. But and for sure, it's not free of charge. That was clarified that it's not free of charge. But again, it could be that there are some agreement with the UN. So probably Vincenzo, you can check. I don't know if Julia, can you put in the link the website of the JEP in such a way that if Vincenzo, and I see also Martin here is from UN Spider. If you are interested, you can directly contact them. Yeah. But if you are interested in general to this problem of landslide, please be advised that we are going to work on this problem at least this year. Again, and so if you want to have also another meeting for better seeing some details about what we are doing, getting more into detail, we are very happy of doing that.
Yeah, thank you a lot to Professor Brovelli for your replies, and also Julia for your hints too. We will check it.
But what are you doing specifically? What are you doing specifically? And where are you based, first of all?
In the Bonn office. So also, hi,
Bonn,
Martin.
yes.
Yes, with Martin, he is a supervisor, my supervisor, with other colleagues, and also with Juan Carlos.
Yeah.
But I am an intern so far, so basically I'm happy to work with them.
Yeah. And what are you doing specifically?
Yeah, my role is about disaster management, disaster risk reduction management, and early warning system.
Okay, so in general, not only landslide, in general on every kind. Okay, okay.
Yeah, a bit
thank
more on
you.
floods. Yeah,
yes,
thank you too.
I see Martin. Hello, Martin. Nice to see you again. No, you have a very strange voice. You seem Donald Duck. I say nice to see you again because I met Martin last week also.
Yeah, indeed, he suggested to join to this workshop. Really, it's an opportunity, a chance to discover, learn a bit more on landslides monitoring evaluations.
Yeah. Let us see if yeah, and unfortunately, because there is when I don't remember which day, there is the inauguration of the new UN center, a geodetic center in Bonn. But unfortunately, these days, I'm in New York to the UN headquarters, and therefore I can't come to Bonn. It will be next time. But I see Martin again. Let us see if your voice
How about
now
this
is
time?
Yeah, This is your voice,
Awesome.
Martin.
Yeah, I have this technical issue sometimes. Like 1 out of 10 cases, my microphone for some reason doesn't work. Then I have to reconnect again. I don't know. I tried to reach out to our IT service. So great to meet you all. Thank you so much for having us. I was invited more or less by Basil and Maria last week at the UMAPS conference to join this. I don't know if you had like an introduction also by Vincenzo, because I wasn't able to join in the beginning. So I could also, if you still have time, just spend 1 or 2 minutes to talk a little bit about what we do and why we're here, and see if there are some potential collaborations in the future, if that still fits your schedule, because I know it's after 12 already. Does it
Yes,
work?
I didn't say anything about UniSpider, Martin. If you want, you of course are.
All right. Yeah, just no. You're an expert as well. I just tried to be short and just to give you some information. So why did I join this call first? I met Maria and Basil last week in Valencia at the UMAPS conference, and Basil told me a bit about these Landslide projects you're working on, and also invited me to this call. So thank you very much for having us. Interesting to see what you're working on. For us at Geoinformatics, it's always good and useful to see what is being worked on in the academic community, and we try to use these events also not just to understand what's being worked on, but also to extend our network, to know which experts we could contact for specific use cases. And what we do, essentially, I think I presented on that last week as well, but just also for all the others here, we support member states and the national institutions, mostly the national disaster management agencies, in using or applying tools, application, workflows, services, and so on, making use of space-based information and technology. For all kinds of disasters and for the entire disaster management cycle. So that's why we try to always be updated on what is being done by service providers, by academia, and so on. And then we try to connect the dots, so to say. We try to connect the space community with disaster management community. We try to connect the academic community with the practical operational community. So we are a bit the sort of bridge builder between both sides, right? So that's why we try to see what's being worked on, and we try to promote applications to the users in the end. We know that sometimes, I've worked for academia for a while too, it's tricky to get results of research and developments out there to the practical users in the end, to the operational services. Procedures are being developed, papers are being published, and of course you want them to be used in the end, or also you might need some feedback and usability studies. Stakeholder engagement, I heard that already. So we try to support that in different ways with our network. As I said, we have a rich network to disaster management agencies. We can use that to promote tools, to connect you, to invite you to conferences we organize. We can present on tools you have developed. You can support us also in trainings. You can give parts of trainings as well. We have like an expert network. They join us sometimes for missions, so events in member states actually. So what we can do, for example, is easiest thing is to publish content on our website, to generate visibility, to create outreach for you and your tools. Perhaps, as I mentioned, use our network for usability studies, decision maker contact, and so on. Other options, trainings, conferences, let me see what else. Allowing you to present your studies. Yeah, and one more thing, sorry, I've taken much time now. More precisely, we have so-called recommended practices. These are step-by-step procedures, how to generate information, maps, or data based on satellite imagery and space-based data. They are on our website. We use them to promote the usage to our target users, most disaster management agencies. We have a lot on floods, on droughts, forest fires, earthquakes, but not surprisingly, we don't have much on landslides. Because it is, compared to others, very tricky and not so, we try to promote these procedures in a way that everybody could do it, or at least someone with basic understanding of GIS, and that's a tricky thing to do for landslides, I understand that. So yeah, I just want to use the opportunity to establish a contact to the Politecnico di Milano and Hanoi University as well, through this network. I can share my email address here, website that we use for promoting content. Feel free to reach out to me. And yeah, also, I think the question that Vincenzo asked was very good already. We are always interested to have procedures that can be, let's say, applied in a generic way, but I know that it's very tricky for landslides because you have so many local parameters. So it's not really, at least yet, easy to do that, but we stay in touch. keep updated on what you and your colleagues are developing, and I hope we can meet again at some point and perhaps get some collaboration going as well. We also have a network of regional support offices. This is like the official agreement that we work together, but that's something we would need to take some steps first. But just to inform you, there's something in this direction, and we can see if there's something we can work on. So thank you very much for having us.
Yeah, thank you so much. It's really interesting. I believe for us as Polytechnico, but also for the colleagues in Vietnam, is absolutely interesting. And again, we will have, we will go ahead in working on that. We will have a final workshop in October, in the end of October, something like that. And so for sure, we'll invite you again. But again, if you happen to come to Milan for some reasons, let us know, because we can have a meeting in person for discussing more in detail what we are doing. And I have to say that what we are developing is in any case based on open source. So we are not jealous for our solutions, and therefore we can make it available immediately. One thing that we have already ready is, as a matter of fact, the all the we can say the education part related then of creating the susceptibility map, because we have the practice with QGIS and with because it's a bit, as you said, the point is that what we are teaching to our students is to create the susceptibility map and then to publish it. So to publish a web GIS for showing it. And so there is the part related to QGIS, but the part related to web mapping, and the practice to the student with some case studies that are shown step by step, or can be shown step by step. So it's this kind of training. I don't say that it is ready 100%, but we can say that it is. We have material if obviously you are interested, and so simply let us discuss. Then on the opposite, for instance, in case of landslide, just to ask you also something concrete. Do you have, because one of the problems for Julia now is to collect landslide. So she's creating this global inventory of landslides. And the basic piece of information that we need is where and when. At least those are the two pieces of information that we need for creating this inventory of landslide that will be reused then by everyone. The idea is to start doing something with Julia, but then going ahead for inventing new machine learning models exactly for detecting, for teaching, for training the machine in detecting landslide. And so if you in your network, you can spread this voice in your network for collecting pieces of data for us, we are very happy about that.
Yeah, definitely. So we don't really have a database ourselves here at Geoinspider, and I wouldn't know about a complete landslide inventory. Everybody's looking for that, right? It seems as though it's not so easy to find, but we can try to spread the word to other academic partners and see what they are doing in this direction. I'm not sure if we know more people in that field than you do, because you are the experts in the field of landslides. But we can try, of course, and just see who responds to it, definitely.
Thank you. Thank you so much. Yeah. And I don't know if our Vietnamese colleagues want to say something also.
Perhaps just some information for the Vietnamese colleagues. We have an office in Beijing. So I'm in Bonn, and we have a focus on the African continent. And we have colleagues in Beijing, and they focus on Asia. So I'd say we, of course, collaborate also inside Geoinformatics. Of course, we are one team, but there's a focus within the Beijing office on the Asian continent. So those would be the colleagues taking care of, for example, missions in Asia. So I would need to, let's say, forward the contact then. But of course, I'm happy to do that.
Thank you. Thank you so much. So again, Martin and Vincenzo, if you want to come to Milan, you are very welcome. If you want to have another meeting for going in more details, that's fine. And but I see that Dean want to say something. Please, Dean.
I'm sorry because today I have problem with the computer. Now I can fix it. But I follow the talk of the seminar, and I see that after 2 years, the project we have been implementing, resulting in quite successful, both in terms of capacity building and also the publication that we already published. And we see that from the first seminar, the kick-off meeting, and after 1.5 years now, we see that beside the implementing of this project, Professor Maria and Vietnamese partner, we also success in secure another Erasmus Plus project that focusing on the spatial technology and digital twins in higher education institution. So I think that from my point of view, that is one of the most success projects that I am participating in. And one of my students, Mr. Dương, Trần Nhật Dương, he is also growing himself a lot in participating in the training course, QGS course, for the application of GS for landslide mapping and assessment. So I think that from this group, we can, beyond this project, we should continue our collaboration. And we also looking for the different source of funding to foster our next generation of scientists. For example, here we see Ms. Dương, also he's also eager to learn. He already applied for the master course in polymer. I support him in this, and also there are several PhD students, one of mine and the other from Hanoi University of Mining Geology. They are also taking part in this group. And I think that this group is quite strong, and the good combination of both the natural science and social science. So we can do together a lot more things in the future. And next week we meet each other in Milan. So I hope that we can have more discussion on this. And from my point of view, so it's very good that we can invite Martin from UN disaster management sector to take part in our seminar, so that the view of him can be very useful for us in the long term. So thank you very much for the team for making it happen.
Okay, thank you. So now I have a final request for you. if people can show them, so can switch on their camera, because Basil wants to take the picture. So thank you, Kyunjie. Oh, I see Juan Quan. Oh, Quan also Nguyen, and oh, many people appearing. Fantastic. And Zhuang answered perfectly my question. Thank you. Oh, yes. And my friend there, ciao. And Professor Vanan, where is Professor Vanan? Oh, the cameras, no, the cameras problems. So I believe that.
I'm sorry. I'm really sorry because my camera had broken down. I don't know, and I cannot fix for that. I cannot
No,
show.
but
yeah,
but the point is that you are too beautiful, and so your
Yeah.
camera
Yeah,
is
thank you.
very is helping us, because if you show yourself, we don't appear so beautiful as we are.
Yeah, thank you very much. Yeah.
Yes, don't worry, don't worry. Yes, okay, perfect. Basil, I believe that you can take the picture.
I took already a couple, but okay.
Okay, fantastic. Thank you, all of you.
Thank you.
And see you again in